So what's all the talk about high pressure in your system? So this system has extremely narrow tubing that is prone to blockages that can cause high pressure in your system at different locations. Additionally, the tubing can be sensitive to high pressure, and if you overload the pressure, you can burst tubing within the system. So it's important to use the appropriate type of tubing within the different locations of the system. Your columns are also very sensitive to high pressure, so you can consult your column manual for the limits of pressure for that particular column that you're using or column sets that you are using. Additionally, high pressure gives you an indication of a start of a problem, of your sample maybe not being in solution, or perhaps maybe your mobile phase could not be appropriate with the type of sample that you would be using. So monitoring high pressure over time will give you an indication of slight increases of pressure need to be dealt with before they become very large increases in pressure that can cause damage to parts of the system. There are many ways to protect your system from high pressure, and we will explain those within the system. So there are filters in place that prevent blockages of your columns or detectors, and those are put in place at different locations, from your mobile phase to your pump to your columns, right before your detectors, so we protect your expensive detectors from high pressure. It's important to know the typical pressure range that your system would be running under conditions of a specific mobile phase, temperature, and column set. So one of the things that we'll walk through is looking at the pressure drops across each part of your instrument to build up to the final pressure that you would be running at a given flow rate. If you see that your pressure is increasing slightly, you can take action based on wherever you see the pressure building up. So let's point out the different places in the system where we might have high pressure. So we'll start with your mobile phase. So sometimes we use a frit on your inlet line to prevent any dust or contaminants from getting into the system. If you do get a lot of dust or contaminants in the system, it could cause that filter become blocked. So it could need replacing. You also want to make sure your tubing is not pinched off or anything like that. That could also cause a lot of very high back pressure on the system, so you want to inspect the tubing as well. The next part of the system would be in the pump compartment. So inside the pump compartment, you'll notice this post-pump filter. Inside of it are two frits that could potentially become blocked. This is one of the reasons why we would like you to use HPLC grade solvents, or if you're adding some sort of salt to the mobile phase, that you also filter with a 0.2 micron filter before using that buffer. This is a way, if for example you get some undissolved salts or contaminants in the mobile phase, this will filter them out before it gets to other parts of the system. So the next compartment would be the Autosampler. So the portion of the Autosampler that could become blocked would be the needle located right here. This would primarily be because of samples that weren't in solution or samples that were extremely viscous that the Autosampler was trying to pick up. If that does happen and you notice that the blockage is at the needle, there is a procedure in the software to replace this needle. The next location is in the detectors themselves. So within the detectors, you want to make sure that all tubing coming into the detector is narrow bore tubing, and all tubing leaving the detector is wide bore tubing, so that you prevent any potential blockages after you've exited the columns. You want to make sure that this doesn't become pinched in the door or anything like that. If it does become pinched or crimped off and causes a source of high pressure, you would want to go ahead and replace that line. Within the detectors themselves, you can see the back side of the viscometer and the 4 capillary bridge. That's a potential source of blockages. And in this model, as you see, we've made it very easy with 4 screws to remove that viscometer bridge, do the replacement within about 10 minutes or so and be back up and running if you happen to find that the viscometer is your source of high pressure in the detectors. If there are other sources of high pressure, such as the refractive index, UV, or light scattering detector, that's quite uncommon, but if that becomes a problem, then you would need to call into our help desk and our service team would be able to assist you. So let's go over to the software and show you where to locate the pressure and how you would monitor it in the software. So within the software, on the left-hand side, you will see instrument controls. If you click on instrument controls, you can see pretty easily here, this is the pressure that I am currently reading, which is 540 psi at 0.75 milliliters per minute. Now I'm running a 20% water methanol mixture, which is pretty typical for just standard aqueous GPC. So in the next portion, we're going to walk you through breaking apart different parts of the system, starting from everything connected, working our way back to the mobile phase, and monitoring the pressure drops across each parts of the system. So we've noticed the pressure at 0.75 milliliters per minute with our aqueous mobile phase is around 540 psi, and I have one column in here at this time. The first thing I'm going to do is remove the detectors. So I'm going to disconnect the inlet of the detectors, and I'm going to observe the pressure drop in the software. This could take a little bit of time just for the pressure to stabilize. So just by disconnecting the detectors, it looks like we've dropped about 80 psi. That's pretty common. It shouldn't be a very high pressure drop. If a lot of the pressure is coming from the detectors, then we would need to call into the help desk and have them help you troubleshoot which detector is causing the problem based on your signal response from each of your individual detectors. So the next location is right before the post column filter, and we're going to disconnect that to see how much pressure drop we get across the post column filter. So to do that, just open the column oven, locate your post column filter, which is right after your column, and we're going to disconnect this line right here. Note that you could also have a blockage in this tubing as well. So if you want to do this piece by piece, if you find that there is high pressure drop in one of these locations, you could also inspect the tubing and just disconnect the tubing to make sure it's not just the tubing itself. So to do this, we're going to need 2 wrenches. So now we can look in the software and check the pressure drop. Looks like it's dropped around 40 psi, which is completely normal for a post column filter that is not plugged. If this drops, several hundred psi or something like that, this would indicate that you need to change the membrane and frits within the post column filter. We have additional documentation to show you how to do that. So let's reconnect and go to just before the column and see how much pressure drop is across our column. So now we're going to disconnect right before the column to see how much pressure drops across the column. So again, we'll take 2 wrenches. So now we can check in the software and see how much pressure has dropped across the column. This should be the bulk of the pressure in the system. So it looks like we've dropped several hundred psi across our column. So the next location is the post pump filter, and we can locate that right here. And we'll disconnect right before we go into the post pump filter. You could also do the disconnection just right after the post column filter and see how much pressure drop you get in between going into your columns as well. But for this demonstration, we'll just take off the top end. So again, we'll get our wrenches and remove this. Okay, so in the software we can now see that the pressure has dropped to 0, which means there's 198 psi on the post pump filter. At this point, that seems a bit high for me for my system, so I probably would replace the frits inside of the post pump filter. So now that we've checked pressure in many locations in the system, we have a good idea of what the overall pressure of the system should be under the conditions for my instrument. If you change conditions, change mobile phase, or change flow rate, or change the number of columns or types of columns that you're using, of course your system overall pressure will change, but you can still have a good idea of each of those zones by doing these disconnects and learning about the different parts of the instrument. You can see from the video there's common places that you might have high pressure. The two most common places are in the column oven with the post column filter, and also the pump compartment with the post pump filter. Thanks for watching. If you have any other questions or concerns, please contact the help desk for additional help.